Hello everyone, and you are welcome to the third session under Unit 2. In this session, we're looking at carbonyl compounds. So at the end of the session, you should be able to use qualitative tests to identify compounds bearing carbonyl functional groups, right? The carbonyl functional groups as aldehydes or ketones and etc. So the first test we are going to look at is the 2,4-dinitrophenylhydrazine test for aldehydes and ketones. So basically, in this reaction, if you have your aldehyde or ketone or a carbonyl functional group, right, present in a compound, and you react this with the 2,4-dinitrophenylhydrazine, then this functionality is produced. Now, a positive test after the addition of your 2,4-dinitrophenylhydrazine is indicated by the formation of a precipitate. And this precipitate could be yellow, could be orange, could be a deep red, and this is attributed to the product that is formed as the dinitrophenylhydrazine. The next test you can look at is the Tollens test. In this test, you add few drops of your unknown to freshly prepared Tollens reagent, and then you gently heat it, and then you observe your color changes or the formation of a new product. Now, a positive test with the Tollens test for aldehydes is the formation of a silver mirror or a black precipitate product. So it could be this black precipitate forming or the silver mirror product, which indicates the presence of aldehydes. And the third experiment that you'll be looking at, you probably did this in the lab, is the Jones oxidation test, the chromic acid test we talked about in the previous slide. And a positive test result is indicated by the presence of this opaque suspension, which is kind of green to blue in a way. So this is also indicative of the presence of an aldehyde, a primary or a secondary alcohol. So except you are dealing with alcohols, they say your unknown is possibly an alcohol, then you can also look at this chromic acid test, because we talk about the chromic acid test in the identification test of alcohols, right? But however, if your unknown is known to bear carbonyl functionality, then you conclude by the fact that the unknown is an aldehyde and not a ketone, right? So now the next thing we can look at is the iodoform test for methyl ketones. So ketones with the methyl group, right, bearing the methyl group as the terminal alkyl chain, we can use the iodoform test to identify them. So you prepare your iodine potassium iodide solution by adding 10 grams of iodine and then 20 grams of potassium iodide in 100 ml of distilled water to prepare your iodoform test reagent. Now the process is as follows. If the substance to be tested is soluble in water, then you dissolve 4 ml of 4 drops of a liquid or an estimated 50 milligram of the solid in 2 ml water in a large test tube, and then 2 ml of 3 molar sodium hydroxide is added slowly together with 3 ml of iodine solution. Then this is used for the test, and then you observe the color changes that is seen. Now, a positive test is seen by a positive test will result in the bromine color of the reagent disappearing in the yellow iodoform solid precipitating out of solution. Right, so that is the positive test result. However, that is for both whether the unknown is soluble in water or insoluble in water. So if the unknown is insoluble in water, then it dissolve it in 2 ml of 1,2-dimethoxyethane, and then the process described previously is used. So whichever approach is being used, the positive test is always the same. So the brown color of the reagent disappearing and the yellow iodoform solid precipitating out of solution. So that is basically the positive test results to look out for.